we're going to do this example, number 15. Now we're going to be talking about brains and brain sizes. And does alcohol shrink your brain if you're an adolescent? Here is the problem we're working on. What's the sample size for this problem?
12 adolescents.
12. That's a really low sample size. What's the variable that's being looked at?
The effect on alcohol on development of the hippocampus.
It's true. That's what they're wondering about. What are they actually measuring to see how alcohol affects their brain?
We wanted to determine whether the hippocampal volumes in the alcoholic adolescents.
Yeah, here's the variable right here. Hippocampal volume. Somehow they're figuring out the size in adolescence of their hippocampus. And that's being measured in cubic centimeters. So it's a number. It's a quantitative variable. What's the population here? We're looking at the brain size of who?
All adolescents.
Yeah, all adolescents. We're going to do a hypothesis test to see if whether or not the hippocampal volumes in alcoholic adolescents were less than the normal volume of 9.02 cubic centimeters. That's the claim here. That's what we're testing. Now we're dealing with averages. So if I'm doing this problem and I'm stating the hypotheses, remember what the symbol for a population average is? Mu. Yeah, lovely, perfect. This is always about a parameter. So we are testing about mu. What's our number we're comparing mu to in this problem? It's in here.
9.02?
9.02. Mu is the average hippocampal volume of, I should say, alcoholic adolescents. And actually, our population here is just alcoholics. Alcoholic teenagers. We're comparing mu to the normal volume of people that don't drink a bunch of alcohol, and we're wondering, is it the same? Is it 9.02? Or what's going to be the symbol in our alternative here? One of these three things.
They want to know if it's less than.
Yeah, we're going to use the middle one here. We want to know if it's less than 9.02. And I could write symbols on here, the average volume, and that's in centimeters cubed. Notice now for a population mean, the hypotheses are about mu. That's step one. Step two is finding the test statistic. Because we're doing a hypothesis test for an average, our test statistic looks like this. It has x bar minus mu naught, s over the square root of n. X bar is just given to us in this problem. S is the sample standard deviation. That was also just given to us. N is the sample size. That was given to us. That's 12. What do you think this mu naught is? We don't have to calculate it. It's the number we're comparing our average to. This particular problem, what's the value of mu naught?
Is it the 9.02?
It's the 9.02. Yeah, it's always the number we're comparing our parameter to. So for our problem, mu naught is 9.02. I have to calculate this. Is our test statistic going to be positive or negative?
Negative because you're subtracting a bigger number from 8.
Yeah, the whole thing is going to end up being negative. The top is negative and the bottom is 0.2021 if I round it right. This test statistic now is a t-score. It's from a t-distribution. To know which t-distribution to use, we have to figure out what's called the degrees of freedom. And just like with a confidence interval, the degrees of freedom is our sample size minus 1. We're going to have to use this to find our p-value. Now, step 3, find the p-value. It's the area under a distribution. This is going to be under a t-distribution. And specifically, it's a t-distribution with 11 degrees of freedom. So our test statistic is way over here to the left. Then how do I know which area that I want? That's based on the alternative hypothesis, which in our case was mu less than 9.02. Our p-value is the area down here. We have to find the area under a t-distribution. Normal CDF was for a normal distribution. What do you think is going to be for a t-distribution?
T.
There's a t-CDF function. And so we wanted to tell it that the right side of the area we're trying to find is negative 4.55.
Oh, okay, that makes sense.
We tell it the degrees of freedom. So when we do that, we get our p-value, and it's going to be quite small. Yeah, I'm getting 4.15 with a bunch of other numbers, e to the negative 4, my p-value. Here's our p-value. So the next step is to make the decision. We have a very small p-value. What's our decision going to be? We're going to reject. So our decision is reject the null hypothesis. So there's our decision. And our conclusion is now we're going to be talking about brains and hippocampus volume. As a reminder, our null was that the average brain size for these alcoholic adolescents was equal to 9.02. The alternative was that it was less than 9.02. And unfortunately for adolescents that drink a lot of alcohol, we have evidence that their hippocampal volume is less. So our conclusion, based on our data, we have significant evidence, not just a little bit of evidence, but we have significant evidence that what? Now we got to talk about a parameter that the average hippocampal volume of all alcoholic adolescents, and what do we have evidence for, is less than, you could say that of normal adolescents if you want, or you can say less than 9.02 centimeters cubed, but it would be totally fine to say less than that of normal adolescents if you wanted to. That's a hypothesis test for a mean.
Question.
Yeah.
Above just a little bit, you compared the p-value to the alpha. Maybe I missed that part. What is the alpha value?
Alpha was given to us. It's the very last sentence of number 15. It says, conduct the appropriate test at the alpha equals 0.01 level of significance. We were just told to use this. This was given.
Compare that to our number that we got.
To make the decision, always compare the p-value to the alpha level. And really, it's true in any hypothesis test. If you're using the p-value method to make the decision, you compare the p-value to alpha. Big ups to y'all for making it this long. We've actually gone over time for a normal class period.
Is that all we're doing today?
Yeah, for sure. Yeah, definitely. That is all I'm going to just hit stop on this, by the way.